Good morning, good afternoon, and good evening, everyone, wherever you might be. Today we're going to do something again a little bit different. It's still going to be related to calculus, but we're going to apply it in the domain of economics. So I'm going to start off with actually a problem that we did. Um, so I'm going to just copy and paste. So basically, it's a word problem. Um, and we're going to use some economic terms, which I'm going to define as we're doing this project. So here's the problem. So suppose we own a pizza place, and the pizza place is called Slice of Joy on the app. So that's the pizza place. On game nights, your pizza sales spike. So the sales spike, that's an important term. But making more pizzas means hiring more staff and buying extra ingredients. And so we're trying to figure out how many pizzas to make to keep things profitable without wasting time or money. Because even though our pizza sales spike, we're able to make profit. However, if we make more pizzas, if we increase our quantity of pizzas, then that also means we have to hire more staff who's making the pizzas, right? And extra ingredients because we need more ingredients to make more pizzas. So what's like um, the right position to be in order to keep things profitable. Like the idea is we're earning more money than what we initially have when we're running this pizza place. Okay, so that's what we're trying to do. And here's what we're given. We looked at our past sales data and we came up with these models. So we have this thing called a demand function. So the demand, from my understanding, but correct me if I'm wrong, the demand is basically the how much the customers want a certain product. So in this case, in our problem here, the demand is how much customers want pizzas, right? And so there's this basic economics graph here. Let's say we have this plane, XY plane. Here we're gonna say this is price. This is the price axis, the vertical axis here. And the other thing, the horizontal axis is what we will say the quantity or the number of pizzas. And the price is, well, how much a pizza is. And so this is what we call a demand curve. So that thing is what we call a demand curve. Why? Well, or how can we contextualize this? In math, well, we can say that the slope is decreasing, right? We can also say at this point, and at this point, the curve intersects the y and the x-axis, right? Or the price and the quantity axis. So that's the math. That's the math behind it. But how do we explain this in economics? Well, if we start at this point here, let's say we have the point zero and some price. I don't know what price this is. So I'm just going to say we start at 50K, $50K dollars. Sure, let's actually say the price is in dollars. And maybe here this is well 40 and $0, right? Because it intersects the quantity axis. That's why the y coordinate is 0. So initially, we have a high price, but we don't have any pizzas, which is not ideal, right? And here we have a lot of pizzas, but we don't have any price for it. And here we can see the slope is decreasing. So how do we contextualize this? Well, actually, if we want to see this in real life, well, we're going to have to scrap this part of the graph because for one, it doesn't make sense, right? So we want to kind of cut this part out. Actually, except this part. This part looks fine. I don't know. You guys tell me. I've never taken an econ class. But yeah. And what's happening here is that as the quantity increases, right? So our quantity is getting bigger, or as the number of pizzas increase, then look at that, our price decreases. That's what we can see here. And so the demand decreases. That's it. That's how we contextualize this in econ. But you guys can correct me. So basically, if we want to put it in real life, well, many people want a thing that's really, really expensive and it's only limited edition. Something like that. Because if there's too many of the same thing, then probably most people won't like it because it's common. But if there's this one special thing and it's really, really expensive, then people will probably like it or will want to buy it. That's why here initially the demand is really high, right? The demand is here. But as the number of pizzas increase or as the number of these products increase, then our price uh, decreases, right? And as our price decreases, our demand decreases. So that's the relationship between quantity or amount of a product, its price, as well as its demand. So that's the demand. Okay. And here we have this model, right? So the model is as follows. So we have Q sub D equals 125 over 4 subtracted to 1/8 P sub D, where Q sub D is the quantity in demand, right? Q for quantity, and this is, well, you guessed it, price in demand. Quantity demanded, price demanded. So yeah. And so this function, we can actually denote this as a function. Whenever we input some price, we get a certain quantity. And so in mathematics, this makes sense because if we look here, our slope is negative, and it's actually a linear equation. There's a linear equation. And this kind of, I'm not saying it's this, but I'm just saying it's similar to that, where it's a linear equation and the slope is negative, so it's decreasing. So that's our demand function, our basic demand function. And we also have this thing called a total cost function. Now, from the definition, we all know that total cost is, well, I can't really give a simple, well, this is self-explanatory, but if we buy a certain quantity of pizzas, then what's our total cost? What's the total amount of money that we will buy or we will spend? So here, in this case, I don't know, if we bought, okay, maybe not the 40 because that's unrealistic. But maybe if we bought, like, let's say, I don't know, if we bought, actually, this doesn't even make sense. We have to make our own total cost function. Maybe a total cost function would look something like, uh, okay, wait, give me a sec. I'm actually gonna write it down first, but we have TC. TC means total cost equals 500 plus 7Q plus Q squared over 100. Oh, sorry, not over 100, over 10. What's okay, without even looking at the graph or graphing it anywhere, Q is the quantity of pizzas. So I can say, okay, this is Q for quantity. And here is the TC or total cost. And maybe it would look, since this is a parabola and its slope is positive, so it's concave up, so it will look probably something like this. Oh, also because it's 500, so I would say probably like that. Sure, we can add this part, but we don't need that part because it realistically it doesn't make sense. Our quantity is never negative here. We can't have negative 5 pizzas. We can only have 0 up to a million pizzas. I'm kidding. 0 up to infinity. Okay, no. But basically, we can't have a negative amount of pizzas or a negative amount of a certain product. So that's why we're not going to include this part. But yeah, this is a parabola in math. And so what's the idea here? Well, as the quantity increases, right? So as quantity increases, well, our total cost increases, obviously. Because the more pizzas we buy or we get, then we have to pay more, right? And so that's our total cost function there. Okay. Now, I keep on yapping about econ because I don't know much. So let's actually look at some problems here. So here's the okay. Here's the catch. Okay, I forgot to mention something. Q is the number of pizzas sold in one night. So number of pizzas sold in one night, right? Okay, so here's the question. So here we want to find the marginal cost. I'm going to explain that later. The marginal cost and marginal revenue. Also going to explain what that means. Functions. We all know what a function is if we've taken math, pre-calculus. So that's our first task. Our next task is how many, so I'm just dividing the problem up to pieces. How many pizzas should you make to maximize profit, right? And another question we have is, what is the price at which pizzas are sold? So here we determined what's the quantity, right? How many pizzas to make in order to maximize that profit. And if we were able to find how many pizzas we have to make, then what's the price of that? Of each pizza. I'm gonna word it a little bit differently. Of each pizza sold. Okay, let's work on the first one. So here we want to find the marginal cost and the marginal revenue. So what's the marginal cost? We all know what a cost is. So a cost is how much an item is. How much this, so in our context is how much the pizza is. How much is a single slice of pizza? How much is a slice of pizza? Marginal cost. If we think of the word marginal, I'm actually gonna Google that because I don't know. Marginal is relating to or situated at the edge or margin of something. That doesn't really help. Uh, Small or not very important. So something along the lines of um, the edge, slight, small, just a little bit. So what can we say? A little cost, marginal cost, a little cost. So something about being small. And since I Googled this, I can say it's something related to being small. So it's a small cost, but where do we get that small cost from? Well, I'm going to give an example. If we sell 10 pizzas, and let's say each pizza costs $10, and then we sell 11 pizzas, and then each costs now $11. So what's the marginal price? Well, it's 11 minus 10, which is $1. So it's that tiny, tiny cost that changed, right? So in other words, let me just look up a formal definition in Econ. It's the change in total production cost that comes from producing one additional unit of a good or service. So it's an incremental cost with increasing output by a small amount. So I'm just going to say it's the change in production cost. Change in production cost. So initially we sold 10 pizzas for $10. Scrap that. This is not yeah, we sold 10 pizzas for $10. And then the next time we sold 11 pizzas for $11. And so the change in that producing each pizza or the production cost. So the production cost of 10 pizzas is 10, and then the next production cost was $11 for 11 pizzas. So the change is 1. So that's what marginal cost is. So how does this relate to calculus? Well, maybe something about if we're given some function, let's say, uh, I don't know, the simple f of x equals x squared. Well, a small change of that would be like, oh, a small change in x dx. So we take the derivative. And if we take the derivative of this function, well, we get 2x. And so what am I trying to say here that connects calculus to economics? Well, if we want to get the marginal cost, then we just want to take the derivative of cost to get marginal cost because it's that small change. Now, let's look at marginal revenue. What in the world is marginal? Well, we know what marginal is. It's the small of something. But what is revenue? Well, revenue is the total earnings that you have. Let me just double check because I'm not Econ guy. But revenue means, yes, the total income a business receives from selling its goods or services before any costs are deducted. So what does that mean? Basically, it's the total earning, the total income. Income means the money you get. So let's say I sold this many pizzas for this price, then that's my revenue. I sold 10 pizzas for $10, that's my revenue. But we actually did not consider the fact that we spent some money to hire to hire workers to make pizzas, and we also spent some money to buy ingredients and all of those other factors. That's because we don't. So basically, the revenue is the total income before any costs or expenses, those are interchangeable, are deducted. So that's our revenue. Now, what is marginal revenue? So again, relating to small or tiny. So what's marginal revenue? I'm actually going to Google this real quick because I cannot explain econ stuff yet. But it's actually a bit similar to marginal costs. But here it's in the context of revenue, hence the word marginal revenue. But it's actually the additional income. It's the additional income that a company earns from selling one more of that something. So maybe to make it related to the first marginal cost, maybe we can say change in income. And again, you guessed it, to get marginal revenue from revenue, then we have to get derivative. So basically, the marginal revenue is the derivative of revenue. Okay, I hope that makes sense. If it doesn't, sorry. I'm not an econ person. And honestly, if I don't get it, then please do correct me. Um, I'm interested in learning more about different applications of math. And right now, I'm trying to explore something related to econ. So yeah, that's that. Okay, now we can actually answer our first question, which is we want to find the marginal cost and the marginal revenue function. So let's do that. So the first thing we want to, well, what's our given? Obviously, we have to look at that. Well, we're given a demand function and we're given a total cost function, right? So what's the first thing we want to do? Well, here we can actually already get our marginal cost because we have our total cost function. Actually, we can. Um, wait, let me see. Okay, so the first thing we want to do, wait, take derivative. Oh no, sulfur Q. Oh, okay. So the first thing we want to do is okay, let's focus on getting our marginal revenue. And before we get our marginal revenue, we want to get our revenue. Because after we get our revenue, we just have to take derivative. And then that's how we get marginal revenue. But to get our revenue, well, let's actually just so that's the first thing. You wanna find revenue function. And to do that, we actually have a formula that is revenue is just equal to price times quantity, right? Do we have a price function? Oh, we actually have our price here, but we don't have we actually also have our quantity here. So we can probably make use of that, maybe? just maybe, right? Okay. Um, yeah. So make or to find our quantity, actually our quantity. Our quantity is what? Q. It's the number of pizzas sold in one night. We're actually given that part here. So in one night, that's Q. Now we need to have our price. So our price is, you can actually get from this demand function here. So we just have to isolate PD in terms of Q, or the quantity in demand, right? So let's do that. So let's rewrite it. So we have our quantity in demand, quantity demanded, which is 125 over 4 minus 1/8 of price demanded. And now we want to rewrite our demand function in terms of the price. So let's do that. Well, QD can be, so here we just want to isolate PD. So QD plus 125 over 4 is negative 1/8 of PD, right? And then we can 125 times 125 over 4. Can we solve that? No. Then we want to multiply negative 8 to both sides. So we have QD PD is negative 8 of this thing. Right? And so PD will give us negative 8 of QD and minus 2 times 2 times 125 minus 250, right? Uh, minus. And we just multiply 8 here. I think, wait a minute. I'm double checking. 125 over 4. Then oh, so we have to subtract. My bad. And then subtract, and then plus. Okay, yeah. So it's PD is this here. So that's our PD. So we can plug in a quantity demanded, and we will get a corresponding price demanded. So it's based on this demand curve that we have. I'm not going to plot it anymore, but it'll look something like that. It's a decreasing linear function in math. And now that we have this price, now we can just multiply the quantity to get our revenue. So let's actually do that. So here, I'm going to change PD to price in terms of quantity. So I'm going to say price in terms of Q, right? And here we have 250 minus 8Q. Now I hope everyone gets that because we're just changing quantity to Q and PD to P of Q just to make it look like a function. And now what we want to get our revenue in terms of Q is we want Q, our quantity, times our price. So Q times P of Q. So we get Q times our price function, and we will get 250Q minus 8Q squared. So here, this is a parabola. So we have our revenue now. That's our revenue in terms of quantity. So if we plug in some quantity of pizzas, we will get a revenue. And Now we can actually find our marginal revenue function as well as our total cost function. We can actually find that already. So we can find marginal revenue, right? And marginal cost. So marginal revenue, we just take the derivative, and that's our marginal revenue, or MR, uh, given some quantity. And so this is, well, 250 minus, what's this, 16Q, I believe? Yeah. And then for our marginal costs, well, this is just our cost function, which you already have, and we just take its derivative, right? Okay, where was it? I lost my, okay. We just take its derivative. Oh, DC. I put DC, I'll just put C of Q, just to say, oh, this is a function. We take its derivative, we get our marginal cost, or MC, in terms of Q. And this will just be 7 plus Q over 5, which I think, yeah, 500, 0, then 7, and then 1 over 10, 5, 5, divided by 5. Wait, let me see. I'm just checking. 1/10 of Q squared. We take the derivative, we get times 2, so we got 2 over 10. Oh, and then we get 1 over 5, so it's Q over 5. Okay, yeah. So this is now our marginal revenue given some quantity or some number of pizzas. We get our marginal revenue. And we also get our marginal cost given some quantity of pizzas. So we solved that first problem here. Now, we want to determine how many pizzas to make to maximize profit. How do we do that? So now we have to determine the quantity, right, of pizzas to maximize profit. So what is profit? Well, if we were to buy ingredients and all of that stuff, and then if we were to sell them, well, we have to sell more than what we initially bought, and that would give us profit. So it's kind of like we earn more money than what we initially spent. That's what profit is. And so to do this problem, well, we want to set our marginal costs and marginal revenue equal to each other. That's what we want to do. Why? Well, here's the thing. If we look at this from a calculus perspective, now I'm going to explain this in a calculus perspective because I cannot do it in an econ. I can do it in an econ explanation, but in calculus, if we take the derivative of two functions, we find their slope or their rate of change. And so we want to find when their rate of change is equal. And so the amount of revenue, I guess, I don't know, but the amount of revenue we're getting or the rate of revenue that we're getting should be the same as the rate of cost that we're getting. And that means we've reached some peak, right? And if we've reached some peak, then that's how we know we've maximized something. Or we've hit something very low, right? So let's see. So to maximize profit, we want to equate both our marginal cost. Okay, I said it differently. Our marginal revenue, I guess, should be equal to our marginal cost. So the slopes of the revenue and the cost, or the rates, should be equal. And at what quantity is that? Well, we just plug in what we know here. So this is our marginal revenue function. This is our marginal cost function. And then here we solve for Q. And if we solve for Q, well, we actually get Q is 15. And so we have to make 15 pizzas to maximize our profit. 15 pizzas in one night. Now that we know what this quantity is, well, what exactly is the profit and the price of pizza per sold? Price per pizza sold. Well, to calculate profit, then we need a profit function, right? And so if we want to calculate what exactly this profit is, so calculate profit and price per pizza sold. Well, we need a profit function. Well, what do we know about profit? Well, actually, profit is just our revenue minus our cost, right? And so we already know what our revenue is. So let's say this is P of Q, which is our profit, right? And this is equal to the revenue minus our cost. And so that means P of Q is, what's our revenue? It's 250 minus 8Q. We subtract that to C of Q, which is 500 plus 7Q plus that thing. So 500 plus 7Q plus Q squared, I think. Q squared over 10. There. And that's our profit function. I can simplify it, but it doesn't matter. I mean, it should be fine to simplify it. Let's actually just simplify it. 250 minus 500 is going to be negative 250. Here we subtract negative 8Q minus 7Q. So we just basically subtract it. And then we have minus Q squared over 10. So this is our profit function. And then here we plug in 15 to get what exactly is our profit. So we plug in 15. And we should get, so let me see. Minus 15 times 15 minus 15 squared over 10. I'm gonna double check just to be sure. So we got 225 divided by 10. So we get, okay, minus 5 minus, is this right? Wait, no. Let me try it again. If it's my computation or, no, this should be right. Okay, now we plug in the 15. Yeah, apparently the answer should be somewhere around 1322.5. But that's weird. I don't know. Yeah, that should have been the answer. But I mean, you saw me compute it. It's a negative number. Unless I messed something up again, which hopefully I didn't. Minus, or I did. I think I did. Or you can try computing for them separately. Mm, 8 times 15, 120. Okay, let's actually try to compute for them separately. Maybe that's why. Yeah. So P of 15 is basically our revenue of 15 minus our cost of 15. And so what's our revenue of 15? Um, I'm just gonna double check it. So oh, yeah, so I did mess up, yeah, because I got the marginal revenue. Or no, what is this? What's my RFQ? Yeah, my RFQ here is different. So I'm just gonna, okay, I'm gonna compute it separately. That's what I'm gonna do. The P of 15 is basically this guy right here. Yeah, so R of 15 is, or R of Q is this, so 250Q minus 8Q squared. So if I plug in a 15 there, I get, uh, oh goodness me, 750 minus 15 squared, 225 times 8, minus 800. Yeah, I definitely messed up the 1950. Yeah, so this is 1950. I subtracted to my cost, and my cost is this. So now I plug in all the stuff I need here. So this is 500 plus 7 times 15. I get 105 plus 15 squared, 225 over 10. I get 22.5. If I add them up, I get 627.5. And I just subtract that here. Okay, now this makes more sense. 1950 minus 627.5, and I got, yeah, so I got 1322.5. Yep, so that's my profit after selling 15 pizzas in a night. So here I was able to make more because it's not negative. My profit is not negative. So yeah. And what's the demand in terms of, did I do here? What did I choose for my demand? For my demand function, I chose, what was this? Oh, I plug in the price and I get a quantity. Or I can plug in the quantity and get the price. Yeah, so I can use my price function here to get the amount of pizzas. Yeah, to get the price per pizza sold, I want to use my PFQ. So I just plug in. Oh, I have two P's here. Okay, I'm using my price. So I'm just gonna say um price demanded maybe, just to make it different. Because I use PFQ here for profit, and I also use PFQ for price here. This is confusing. I'm just gonna say price demanded here in terms of Q. Yeah, and then this is just Q. So my price demanded in terms of Q. I'm still gonna use the same thing, 250 minus 8Q. And I get 130. So that's pretty expensive. Yeah, that is really expensive. But I hope you guys get it. So that's $130 to sell those 15 pizzas. So it's the price per pizza. So 130 per pizza. Okay, so that's the idea. Now we're gonna do something. Actually, I'll do that for the next video. But yeah, I hope you guys learned something, and I'll see you all in the next one.